In economics, the Lorenz curve is used to represent the inequality of income distribution among different groups in the population of a country. On the left, you can see a table for the US income distribution for 2018, and this is how you interpret that data. So this row says 0.2 for the input and the output is 0.052. That means that the bottom 20% of the US population owns just about 5.2% of the wealth in the country. Similarly, the bottom 40% shares about 15.5% of the wealth in the US. And so the way that inequality of income distribution is measured by the Gini coefficient of income, which is defined below, but let me just show you why we care about finding the area between two curves. So it's not graphed here, but I'm about to kind of add it on here. So this is the line y equals x. And basically, we are, with the Gini coefficient, we are finding the area between these two curves, where the bottom curve or the lower curve is created by plotting the points on the Lorenz curve from the table to the left. So we have the line y equals x here as our upper function, and then our lower function is this function here highlighted in blue. And the closer the Gini coefficient is to 0, that means that there's more equality of income distribution because, for example, 20% of the bottom population owns 20% of the income. So if this were closer to that line, as the area of the yellow region gets smaller, oops, that's not what I meant to do. As the area of the yellow region gets smaller, that income or the wealth gap decreases and is spread more evenly across the population. So I mentioned the Gini coefficient of income earlier, and it's defined by this formula below. So it's the area between y equals x and y equals L of x divided by the area below y equals x, which that is equal to 1/2. So we are basically taking an integral of the upper function minus the lower function, and we finally get this formula where the Gini coefficient is equal to 2 times the definite integral from 0 to 1 of x minus L of x dx. The function y equals L of x is this 4th degree polynomial, and that models the 2018 income distribution data that you can find in the table below. Above. Part A says use L of x to find the Gini coefficient of income for the year 2018. So Gini coefficient is equal to 2 times the integral from 0 to 1 of x minus L of x dx. So that equals 2 times the integral from 0 to 1 of x minus 2.2656 times x to the 4th minus 3.3414 x cubed plus 2.1434 x squared minus 0.0686x plus 0.0005 dx. So I went ahead and I simplified the integrand in that first line that we see here. And in the second line, I went ahead and I integrated, and we see that we need to evaluate that new function for x equals 1 and x equals 0. Thankfully, every term has an x in it, so if we plugged in 0, it would all become 0. So then this is going to become 2 times negative 2.2656 times 1 to the 5th power over 5 plus 3.414 times 1 to the 4th power over 4. And 1 to the 4th and 1 to the 5th are just 1. So let me in fact, go ahead and erase those. Minus 2.1434 over 3 plus 1.0686 over 2 minus 0.0005. And I could put times 1 or just leave it like that. Notice I dropped some of the ones later on, so I'll just go ahead and erase these as well. And I went ahead and I threw that into my calculator and I got 0.403367. So that is the Gini coefficient for the US population in 2018. Part B of this question says, if the Census Bureau Gini coefficient of income for 1991, so 1991, the Gini coefficient was 0.428, during which year is the distribution of income more nearly equal? Now remember, we wanted it to be closer to 0 to have a better spread of the income inequality. So that means that in 2018, the distribution of income was more nearly equal than in 1991.